Okay, so today we are going to see conditions and loops in R. This is one of the most exciting topics in programming and also especially in R. First of all, I will start with conditions in there, and we will see if statements and else statements. Also, we have if else for element-wise checks, and we will try to nest and stack statements, and we will see the switch function as the last function in conditions. Okay, and after conditions, we will move to loops, and there are several loops types in R and maybe in general programming. And general, their meanings are very similar when you see some loops in Python, for example, or in C++, and that can be the same in R. Only the body of the code chunk may be different, slightly different than each other. So in loops, we will cover 4 loops as a first step. Then we will try to nest that 4 loops. And after that, we will jump to while loops, break or next statements, and as a last step we are going to see the repeat statements in here. Okay, so because of the philosophy of these conditions and loops, we will have lots of talking today, maybe less typing when we compare with the previous lectures. And please try to get the idea and stop me if you have any questions in anywhere. Okay, so let's move to conditions. So if you want to control the flow of your order of your execution in your code, you should make the execution of certain sections of your code dependent on a condition. Okay, so another basic control mechanism is in here is loop. And loop is repeating a block of code a certain number of times. Okay, so these core programming techniques are explored by using if or if else statements, for and while loops, and other control structures in here. And we are going to start with if statements as a first step. Let's just start with if statement in here, and an if statement runs a block of code only if a certain condition is true. So what does it mean, guys? You are just adding a certain comment in there or your code in here, and you are giving a condition. And if your condition is true, then R is running your statements in there. Let's say the pseudo code in here is going to be something like this. You don't have to write this part, guys, okay? So here is my pseudo code in here. So I have my if condition. I'm starting with if, and I'm just adding one condition in here. And if this part is true, if this condition is true, R is just running this statement, okay? So in here, your condition must be an expression that yields a single logical value. What does it mean? You should have true or false. If it is true, the code is in the braces in here. If it is true, your code is running to here, and this part is be executed, okay? If the condition is not satisfied, then you just skip this part, okay? And R does nothing in here. Or continues on to execute any code after the closing brace in here. Okay, let's see if I can write a real example. Maybe you would prefer to write with me, guys. A is 3. What is that in here in R? What is the name of A?
Variable.
Yeah, this is an object in R. And B is, let's say, 4. And I want to add my if condition in here. If A is smaller or equals to B, I want to do, oh, sorry, guys. I want to do something. Okay, okay. If A is smaller and equals to B, I want to get A squared in here. Okay, okay. Okay. So you already run your A and B. You can see it in your global environments in here. Your A is 3, your B is 4. And this one is your conditions, guys. You are just looking for this one. Maybe you want to check out. You see that A is smaller or equals to B is true. What does it mean? Then R is going to run to the next part and just execute this part in here. Let's run all of them. Okay, and when you just see what is the new value for A, you will see that A is 9. Okay, what if you run this part one more time? What happens if you run this part one more time?
Because the A is not smaller than B, it won't execute.
Yeah, it is not going to.
False.
Excuse me?
Will it print false?
Yes, when now A is 9, when we just run this condition in here, you will see that this is false. And then R is just skipping this part, and now just run this part one more time, and you will see that nothing has changed. A is same in here. So did you get the idea, guys? Do you have any questions, comments?
I think it's pretty clear.
It's clear for Ahmad. And what about you guys?
Can I ask something?
Sure.
If we want to do two things, like A equals A squared and B equals B squared, for example, should we put semicolon?
Let's try. No. We just add B equals B squared. Sorry. Oh. Okay, okay. We should run this part one more time to make sure our if statement is working. And here is A and here is B. So maybe you remember that we don't have semicolons in R, but if you want to put them at the same line like this, you should add a semicolon, okay? But generally we don't use that much, but since they are very short sentences, maybe it's a good idea to add them on the same line. Just run this part and you will see we have the same one. Okay? Any questions, comments? Are we clear, guys?
All clear.
Okay, thank you. So let me remind you some logical expressions in R, okay? I want to remind you some logical expressions in here. And I will, okay. I will share some part of my screen portion in here with you guys. And here is what? Can you see these logical operators in R?
Yes.
Okay.
Yes.
So this is just a reminder in here. And we have some logical operators. R is just carrying them in Boolean operations like AND or, okay? So if you are using this guy in here, you will see this is logical NOT. And if you have AND, that means you are just comparing them element-wise, and this is element-wise logical AND. And if you have two, this is just a logical AND. And if you have this guy, that means this is OR. If you are using just a single one, that means you are looking for element-wise logical OR. And if you have double, that is logical OR. And we will see some examples. And I think this is going to be much clearer for you guys after seeing that examples, okay? So I also added some small explanations at the end of the table. You will see that these operators of AND and OR perform element-wise operation, and they are producing results having length of the longer operands in here. But when you have double AND, and double OR, they are examines only the first element of the operands in here, and this is resulting into a single length logical vector. So if you please keep in mind that if you have 0, that means false, okay? 0 means false, and your non-zero numbers are taken as true. Let's see what I am talking about. And let's share again with my R Studio. Yes, this guy. And we are going to see some examples about these logical operators in R. Let me first define a vector including true, false, 0, and 6, okay? Here is my X. Maybe you want to see here. And here is my X. I have true, false, 0, and 6. And when I have Y, I want to define it with all logical expressions in here, I mean true, falses. And I have my false, 1 true, false, and true in here. Here is my Y. If you want to look for X naught, just do that, X naught, and you will see in here I have false, true, true, false. And maybe you remember X is true, false, 0, and 6, and X naught is false, true, true, and false, just the opposite of X. And when you just check out for the numbers in there, okay, true, false is easy. You can just see true is false, false is true. But in here, 0 is false for R, then it's going to be true in X naught, I mean. And 0 is false. I mean, the 6 is false because it was true in natural, okay? Did you get the idea in here? Any questions, comments?
All clear.
Okay.
I think it's pretty clear as well.
Okay, okay. If you have X and Y, and if you just run this part, false, 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 true. Do you know where it's coming from?
Yeah, isn't it the truth gate equivalent of their function?
Yep, I mean, if you have true, false, that is, if you have true and false,
It's false.
yes.
If you have true and true, it's true. And
Yes, only true
continue
and
like that.
true is true if you are using and in here, and the rest of them is going to be false. And what if we use double and instead of single one? So instead of single one, just add double and see what's happening. Oh my gosh. Now you just get one false in here. Did you get the idea? If you have double of them, only the first elements are compared and you only have one answer in there, okay? The first one was...
since the one false is their common element because it is printed.
No, because it's just looking for the first element. That means it's just comparing true and false, and true and false is false, and it is just giving you that answer in there and not element-wise comparison.
Okay.
If you are looking for element-wise comparisons, then you should have you should use a single and in there, okay?
So does it mean that and operation is not that much useful for us?
Sometimes it is, but not in this case, okay?
Okay.
Let's move to OR. Let's say I'm comparing X and Y, and you will see that true or false is true. Again, false and false or true is true. You have false or false, that's false. You have true or true, and that's true, okay? So if you just check out for double OR, that means you are just looking for the first element in there, and you will see that you only have the true as a first element. So did you get the idea what's happening in there? Do you have any questions, comments?
I think it's pretty clear again.
Yeah.
Perfect. So let's see another example. I want to generate a vector. Sorry, guys. Okie dokie. I want to generate my vector in here with some numbers. 2.73, 5.40, 2.15, 5.29, 1.36, 2.16, 1.41, 6.97, 7.99, 9.52. Here is my vector. I want to write my vector on the screen, and let's see the length. I'm just curious what was the length, and I have just 10 elements in my vector. And now I want to generate a matrix in here. Let's say this is my matrix, and I want to use 2, 0, 1, 2, 3, 0, 3, 0, 1, 1, and 2, 0, 1, 2, 3, 0, 3, 0, 1, 1. And let's get 5 rows and 2 columns. And just write my matrix on the screen, and you see I have 5 by 2 matrix in here. Now I'm going to write kind of a more complicated if statement in here to make sure we had enough example. So
Hocam,
I have, excuse me.
bu and ve or'ları sadece karşılaştırma yapmak ve loop için mi kullanıyoruz, yoksa hani true false elde edemediğimiz durumlarda da kullanabiliyor muyuz?
So we are going to use them for some comparisons, but I'm not sure what you are meaning with the situations that we cannot get true or false.
Ya işte hani atıyorum kelime falan yazdığımız zaman da kullanabiliyor muyuz? Yani onları da mı true olarak basıyor? Hani A, B, C direkt harf olarak yazdığımızda.
Let's see what she means. She said that if I just add A in here, so R is not able to write A because it's a vector.
Hı
It
hı,
has to has the same type, okay?
tamam.
Even I add something like this one, R is going to shift all of them to the same class, okay?
Tamam hocam.
We are not able to add the number and the character at the same vector. But of course, we can always generate lists to mixing types in here, okay? You can just use lists. So now please keep in mind that I have one vector and also one matrix in here, okay? And I want to do some comparisons in here. So if I will add any at the beginning of my comparisons, and so that means any of these conditions is satisfied, okay? Any means if any of these conditions are satisfied, that means I'm going to give more than one conditions in here. So let's first say something like my vector -1 if it is greater than 9, okay? Or I'm going to generate a matrix and with my vector and 2 times 5, and we'll get the second and the first element and just check out if it is smaller than 6. So in here, if any of these two conditions are satisfied, this one or this one, then run rest of them. So please cat condition is satisfied, okay? And also I want to generate one more thing in here. I want to generate a new vector, from my vector. And in my new my vector, for the elements from 1 to 9 by 2, I want to change them as NA in here. And also I want to generate a list, my list, and just use list function. And in this list, I will have AA element, and which is going to include my vector, my new vector.
Hocam, you're going too fast.
Okay.
Yeah,
So
can
let's
you
just
please?
start over, okay?
Thank you.
In if, I'm just adding any, and if any of these conditions are satisfied, it doesn't matter, this guy or this guy. And I'm just, R is going to run this part. First thing, if this is true, any of them is true, first thing is going to be that this is written on the screen, cat. The condition is satisfied is written on the screen. Maybe you will see that if you run this part, cat, R is giving you written sentences on the screen, okay? And after that, I want to generate a new vector from my vector. Here is my vector. You will see that it is exactly the same as my previous vector I defined before in here. But for these guys from 1 to 9, 1, 3, 5, 7th and 9th element in my vector in here, you will see that this is the elements. I'm going to change them with NA and just run this part. You will see that now my vector, you will see I'm going to change them, okay?
Okay, can I ask something?
Sure.
In line 35, you wrote any, but if we didn't write any, we would get the same answer.
Yeah.
Right?
Yeah, maybe. But I'm just trying to give you one more
Okay.
options, just trying to add one more example in here, okay?
So if we had and instead of or in line 35, it will, if we write any, it will consider this condition as or, right?
Yeah, I guess so, but maybe we should try it after we run this part, okay?
Okay.
So here,
Hocam, bölüyorum ama cat fonksiyonundan sonrasını bir daha anlatabilir misiniz?
so in here, this is just an example, okay? This is not always happening like that. Just keep in mind that. In here, if this condition is true, then R is going to cat something. Then R is going to generate a new vector. I want them to have a new vector. And in this vector, the odd elements is going to be NA. I'm just changing the elements in here. Okay?
Tamam hocam, teşekkür ederim.
And I am generating a list by using list function. This is another option that you can add or not. It's up to you guys. I have my first element, and please write my new vector inside. And also as the second element, I want to add my matrix and add 0.5 to each element in here. And as a last step, I want to cat again. And let's see. I want to write a list with, just give the length of my list. And members now exist. Okie dokie. So right now I want to remove list. How we were removing everything? Do you remember what we were writing in here?
ls and then empathy parentheses.
Perfect, thank you. So my environment is now empty because I don't want to have them. I will generate them if this condition is satisfied, okay? And here is my vector. Here is my matrix. I have my vector and also I have my matrix. And I will just subtract 1 from each element. And if one of them is greater than 9 or any condition in here is satisfied, let's see what is this. I'm just converting my vector to the matrix and just getting this element, which is 5.4. And so that means this condition is satisfied. Now run this part. And this condition satisfied, a list with 2 members now exists. This is my output in here. And also I have new elements in here. One of them is new my vec. Here is my new vector. And you see that also I have my list. And in my list, I have my first vector as element AA. And also I have a new element, which is a matrix, and just adding 0.5 to my matrix in here, okay? So that means we have some kind of different, we can have a serial number of, I mean, the calculations we can do in there by using conditions in here, okay? So in this example, we have 2 conditions. Yeah? Oh, where are they?
Sure.
So in this example, we have 2 conditions and they consist of 2 parts separated by an OR statement and which just producing a single logical results. And you just walk through it. Please try to walk through it by yourself in here. So the first part of your condition looks at my vector. You are just looking at your vector and just taking 1 away from that vector from each element and checks whether any of the results are greater than 9. So if you run this part on its own, you will see that my vector minus 1. Oh, sorry, guys. Just run this part and you will see that you don't have any true in there. So this condition is not satisfied. Okay. And now the second part of the condition uses positional matching in a call to matrix to construct a 2-row, 5-column and column-filled matrix using entries of the original vector in here. Then the number in the second row of the first column of that result is checked to see whether it's less than or equal to 6. So what does it mean? You are just having this guy from your matrix. Just get your guy and just check out if it is true or false. You see that this is just true. This means the overall condition being checked by the if statement will be false or true, then that's going to be true. And you're just getting true. That means R is going to run all these parts for you guys, okay? So just run this part any, and this is going to be true. So maybe you can just try this part just by omitting any, or also by changing this guy to and see what's happening in there, okay? This can be exercise doing by yourselves and see if it is working if you don't use any, or if you change, and what happens if you just change this or to and. And so,
I have a question.
Sure, Matt.
Now, because that we have two bar characters here, we are only checking the first elements of both vectors, right?
Just checking
But
for
the second vector is 2 and 1 elements of second row's first element. Okay, it's already one element vector. Okay.
Yep, it is already one.
Okay.
But it can be more than one element. Since you are just using the double or, then it's going to use the first ones in there for both, okay?
Okay.
So you have false or true. That means you have true and your if condition is satisfied. As a result, the code inside the braces is accessed and they are executed, okay? Because I have true. So what will happen in there, because I have true, first of all, it prints condition is satisfied. When we run this part, it just print condition is satisfied string, and it is going to copy, I'm just highlighting where I am talking about it, and it just copies my vector to new.myVector, and using sequence in the here, it then accesses the odd numbered indexes of my new.myVector and overwrites them with NA in here. Next, it is just generating my list in here. And in this list, new.myVector is stored in a member named AA, this part. And it takes the original of my matrix and increases all of its elements by 0.5 and stores the results in BB. And it just prints the length of the resulting list in here, okay? Did you get the idea?
Yes.
Okay.
Can I ask something?
Sure.
I have tried the same example with and, but it didn't execute this the if statement. So it means that now I'm.
So after if statement, now we want to move to else statements in R. So we know that if is just executing some code chunks in here, and inside it's these braces, and first, so inside its braces, if and only if a defined condition is true in here, okay? And if you want to something different to happen when the condition is false, you can add an else condition. Maybe you remember that when our condition is if, when you have true, then it's going to run, and if it is false, and just it is executed. It's not, I mean, that it's just, it doesn't run the rest. But if you want to do something different than happen when the condition is false, you can use else condition. Let me just add a pseudocode for you guys. I want to add a pseudocode in here. You see that you are just adding a condition for if, and if condition is true, R is running this part, else R is running that part, okay? Let's write an example, a basic one first. And let's say if A is smaller or equals to B, cat, the condition was, let's write the condition A is smaller or equal to B, and just get the square, oh sorry guys, square of A. Okay, now this part is done. We say else, and cat, write your condition in here. This is optional. You can add whatever you want in this part. A, B, so now you have two options. Maybe you want to remember your A. I think we remove A. Do you remember what was that? I think it was 3. Huh?
Yes, A was 3 and B was 4.
4. Yeah.
B was 4. Okie dokie. So when we write this one, and you are just saying if the condition was, in this case, condition was true, and if you want to see your final A, you will see it is 9. So let's say if we run this part one more time, then the condition was false this time because our A is now 9 and it is not smaller than B. And now this time, this part is going to be executed and your A is 5.5. Okay. So let me explain this part one more time. As a first step, we want to define our A as 3 and our B as 4. Our condition is A is smaller than B, and maybe you see that this condition is true. What does it mean? When I first run this command, this code, R is going to run this part and doesn't have to go to the else because the condition is true. Okay, let's run. And the condition was true, and my A is now 9 because R ran this part. But if I want to run the same if one more time, this time my A is not smaller than B. You see that my condition is false now. And if I run this part, R is going to skip this part because this is not true. And it's just moving to the else part. And now it's just saying that your condition was false because this is false. And now new A is the one that is subtracted by 3.5. Okay, did you get the idea? I think it's kind of fancy in here, huh?
Yeah.
Yeah, the idea was pretty clear.
The idea is clear in here, yeah. It's just speaking in English in here. If this is true, run this part and also change my A to the A square. And if it is not, then just run this part and also new A is A minus 3.5. That's how it is working. It's just like speaking, okay? So if you are clear with if and else, I want to move to if else. Okay, we also have if else for element wise checks in here. An if statement can check the condition of only a single logical value. Okay, maybe you remember that if is just checking for only a single logical value and it's just looking for a single true or single false. And if you pass in, for example, a vector of logical for the condition, the if statement will only check and operate based the very first elements. And it is going to use some warning saying you that something is happening in here. Let's see what I'm talking about. Maybe the example will be explaining much clearer than me. So I'm just adding if. Let's add a vector with falses and trues. Okay, false, sorry guys, true, false, true, and true. and I want to run something. If you run this part, you are just getting a warning message. In if the condition has length greater than 1 and only the first element will be used, okay? Please keep in mind that. However, a shortcut function is available which can perform this kind of vector-oriented check in relatively simple cases in here. So to demonstrate this one, let's see an example. I want to see I have a vector x equals to 5, and also I have a vector y, which is from -5 to 5, okay? And let's run y, and you will see it is a vector from -1 to 5. Now, please suppose that you want to produce the result of x over y, okay? You have x over y, and maybe you have one infinity, you see that? Because you have 5 over 0, that means you have infinity. And if your vector is divided by 0, then you want to replace this infinity with NA. In other words, for each element in Y, you want to check whether Y is 0 or not just for the first one. So, if you have that infinity also, you want to code to output to NA. If not, it should output the result of x over y. Okay. So let's run. Let's say you want to check if y is equal to 0. You will see that you have falses and one true in here. Okay. So if you want to use the element wise if-else function for this kind of scenarios in here, let's write a result. And you want to use if-else. And here, the first one is going to be your test statement, okay? Your test statement is if my y is equals to 0. That's an interesting scene. And if it is yes, please change it to NA. If it is no, then please just get x over y. And here is what you are doing in here. Now you are just having x over y again, but this time if you have your y is equals to 0, if it is true, then you are just changing it to NA. And for the rest of them, you are just doing your normal algorithm in here. I mean the mathematical equation in here.
Okay, but this is the first time I'm seeing like a loop that's kind of in this format. Like I don't think we covered if-else statements in C and Python, but we never had the test yes and no statements. So is like R unique with this format, or is it something that's actually pretty common?
This can be used for different programming languages, I guess. This can be used, but they may have different types of functions in there. But in R, how it is working that you are just adding if-else, and the first one should be your test. And then the first one is going to be the answer of your yes, and the second one is going to be x over a. But it's just a very simple example, okay?
Okay,
It may not be that common in general. Okay, but I think it's good. It may be helpful for you guys in some cases. So also there's one thing with if, and you can just nest or stack statements in if. What does it mean? That you may have some if inside of your if statements in here, okay? So that means if statements can itself be placed within the outcome of another if statement. So that means you are nesting or stacking several statements, and you can weave intricates in here the paths of decision making by checking a number of conditions at various stages during execution in here, okay? So I'm going to kind of write a more fancy example and see how it is working, okay? I don't want to write it by hand. let's first write give some objects and vectors. Let's say my A is again 3, and I want to define my number as 4. Okay, I have A and I have my number, and I want to add something like this one. I have my if statement. If it is true, I will do something, okay? This is the outer if statement. And in here, I also want to add some else, do something, okay? So instead of this if statement, if my condition is true, I want to add some more if statements inside of them. So that means you can combine your ifs by nesting and stacking, okay? So for example, let's give a condition. First of all, you should say that I have a condition in here. If my number, my A is smaller than my number. So that's easy. You can just answer that, sorry guys, as true. My A is smaller than my number in here. So if this is true, you want to say something that, let's say you want to cat something. First condition was true, okay? I wish I can write true. Okie dokie. Now, I also want to change something. I want to get the square of A, okay? So, inside of this if, I want to add one more if. If something is true, please do that R, okay? And if it is not, so I have else again, and just do this part, okay? Now, inside if, I want to add one more if in here. So here is what. I want to give one more condition. Let's say my number is greater than 3, okay? So here is my second condition, and just say cat second condition was true, okay? I wish I can write true. So then this time, I want to change B. I want to generate a new B actually from sequences from 1 to A, and the length is going to be my number, which is 4, okay? And if this condition is not true, I want to run this part. That means maybe you can just say to R, the second condition was what? True or false?
False.
Yes. I know it is getting ugly, but it's just an ugly example to make you understand that part, okay? B is equal to A times my number, okay? Now, I'm still inside the first condition. Please keep in mind that to run all this part, you should have this condition as true, okay? If this condition is true, R is just running this part and also checking for a second condition. And if it is true, R is running this part. So you may have different combination depending on truths or falses, okay? If your first condition is not true, R is just running, just skipping all these guys and just running to these parts, okay? So what does it mean? So I'm here and I'm going to say that first condition was what? True or false?
False.
Yeah, to move there, that means my first condition was false. And now my A is going to be A minus 3.5, okay? Let's add one more condition in here. You are able to add whatever number you want in here, and you can just add one more if. And if this condition is true, then you are saying something in here. And if it is not, then you are saying something, okay? So you just check the first conditions, then you see that it is not true, and R is just skip that part and running here and writing this guy and changing a, and you want to add one more condition in here. Let's say my number is greater or equals to 4. If it is true, just write cat second condition was what? True or false?
Second condition is true.
Yes, this one. Second condition is true. And you want to change B as A times 3 minus my number. This is something you want to change. And you said else, sorry guys. And now I have else. And if it is not true, that means cat second was what? True or false?
False.
False.
False. Bravo. Now you have B again, and you want to rep and add A plus my number, and you want to repeat that how many times? Let's say 3 times, okay? Now, wow. You have some if inside your if. Let's see what is my A now. A is 3. What is my number now? My number is 4. You see that? And now, depending on these conditions, let's run and just run this part. And you will see that first condition was true, second condition was true. That means R just run this part, okay? And let's, it should be.
Professor, that was a tiny bit overwhelming because I think it's kind of like we threw everything we know in R in like a single block, you know, so.
Not indexing. We didn't add any indexing in here.
Yeah, that's true, but I need a second.
Okay, yeah. We are going to digest this part, okay? We are going to digest. So what happened in here that your first condition was true because your A is 3 and your number is 4. That means this is true. And R is went there and just run this part. And now A is A square. You see that? Now A is 9 because this was what was true. And you also check out if your number is greater than 3. Let's see. And this was also true. And now you have a B. Your B is a sequence from 1 to A, 1 to 3, and length is 4. And you can just run this part, you will see. And this is not run by R because these two guys are true and this is just skipped. And also this part is skipped because this first condition is true. But if you want to run this part one more time, just check out what is your A. Now your A is 9 and my number is 4, okay? So if you just check out for this guy in here, you will see that it is false. And now when you run if statement one more time, R is just running to line 83. So let's run this part one more time. And you will see that first condition was false. Second condition was true. What does it mean? Now, first condition was false and second condition was true. And I want to see my new A. A is 5.5 because now R run this part. A was 9. 9 minus 3.5 is 5.5. What about B? B is something 8 times 3 minus my number.
It's 0.181882.
Yeah.
Yeah.
This is my B. And now I see that part. Okay. So what should you do in here is that maybe you have to repeat that part and try to run the same code by yourself, point by point, okay?
I have a question. So right now we need to, like, every time we did it, we manually redid the if like conditions, but is there a way to tell R to repeat every if statement twice? I mean, like, repeat the first condition like twice.
Yes, so you should write some functions in there or some loops in there. We will see that part too.
Okay, sure.
Okay.
Don't we have any if and else if loops, like, or not loops?
Yeah, why not?
You know, statement.
Yes, you can also just use if and also if else at the same time.
So it is like the same usage as if and else.
Yes, maybe you remember if else statement and you can just embed that part into your if statement depending on your problem you want to solve in there, okay?
Okay, so I can write, for example, if and then if else, then if else, then else, for example, right?
You may have if and you may have as an outer conditions. And inside
Okay.
that if, you may have whatever you want. You may even have a very big function, okay? It doesn't
No, but
matter.
I didn't mean that. I meant, for example, if A is less than my number. If it is not true, then if maybe my number is bigger than, not bigger than, if my number is equal to 9. If it is not, then if dot, 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 dot.
No, you should say else there. If, and
So-
if somewhere you should say else. Maybe
I
you
mean,
should
For example,
prepare.
in Python we had if and else if statement. Do we have such a thing here?
In Python
So
you
that
have
if
what?
the first if else statements, for example, if the first condition is not true, but the second condition is true, then do that. But we have more than one condition. Let's say we have 4 conditions.
So you can add them, all of them inside there. It doesn't matter how many conditions you have in here.
No, but I don't
You
mean
can have
nested.
if, and if several times. It doesn't matter.
Okay.
Okay. So you can also try this one with new numbers. Let's say A is 6. A is 6, my number is 4. And when you just run this part, now you will see that your first condition was false and your second condition was true again. Okay. And what is happening in here is that, and the initial decision being made as earlier, the value A is squared if it is less than or equal to my number. And if not, it has 3.5 subtracted from it, okay? And also, after that, now you have another if statement within each braced area. If the first condition is satisfied, then A is squared. You then check whether my number is greater than 3. And if it is true, B is assigned a sequence of something. And if false, B is assigned A times my number, okay? So if the first condition fails and you subtract 3.5 from A, then you check a second condition to see whether my number is greater than or equal to 4. If it is, then B becomes A times 3 minus my number. If it is not, B becomes rep of A plus my number times 3, okay? This is what is happening in here. I would recommend you to some self-working in here, okay? And Now we are going to talk about the switch function. So let's say you need to choose which code to run based on the value of a single object, okay? One option is to use a series of if statements, and you can compare the object with various possible values to produce a logical value for each condition here. Here's an example. I just want to add the example. Maybe you don't have to write it. So here is an example, and also kind of answering the question of Leka, I guess. Huh? And now
can
we
you send the
have...
code in the chat? Hocam, can you send it in the chat?
Sure. I send it there.
Thank you.
So we have a string in here. Now this is, I think you were asking else if, Leka. So we have a string in here, it is Lisa. So you have some values and simply assign a numeric value to an object foo. If your string is Homer, for example, your foo is 12. Else, if your string is March, then your foo is 34. Else, if your string is Bart, then foo is 56. Else, if your string is Lisa, then your foo is 78. Else, if your string is Maggie and foo is 90. And also, as if none of them is true, then your foo is NA. So here is my string, and when I run this part, now my foo is what? My foo is 78, because this condition in here is true, then my foo is 78, okay? This is not so quite useful to use that much else ifs inside of them. And in here, you see that there's 5 different possibilities that your string can take. It can be Homer, Marge, Bart, Lisa, or Maggie in here. Okay, and then your foo is defined depending on these 5 values, or none of them is matched, then foo is going to be NA in here. So this setup using if-else statements is quite cumbersome for such a basic operation in here. This is kind of a basic operation, but we are using lots of else if or if else's in here, depending on which part we are looking for. But you can see them as if else, if else, if else, okay? This is just an easy way to show. So R can handle this type of multiple choice decision in a far more compact form by using switch function in here. So let's say you have your string as Lisa, and instead of that much else if, we have a switch function. Then your foo is going to be, I have my switch function in here. The first one is going to be your expression. Your expression is my string. If my string is Homer, then foo is 12. If it is March, then foo is 34. If it is Bart, it is 56. For Lisa, I give 78. For Maggie, it is 90 and NA. Now, when you run this part, you will see when you check out for your foo, again, it is 78. And believe it or not, this chunk is doing the same job with this guy in here. Okay. Now I want to change my string to Peter. And when I run this part one more time, you will see now your foo is NA because you don't have any Peter in here. You have Homer, sorry guys, Homer, Marge, Bart, Lisa, and Maggie. So the first argument, which is expression, is the object of interest and can be either a numeric or a character string in here. The remaining arguments provide the values of operations to carry out based on the value of expression in here. If expression is a string, this argument text must exactly match the possible result of expressions. So you see that the switch statement evaluates to 12 if my string is Hammer, 34 for March, 56 for Bart, and so on. And the untagged value, the last one, is going to be NA. This is indicating that the result, if my string doesn't match any of the preceding items in here. Okay? So we can also use the integer version of the switch instead of strings in here. It's slightly different. Instead of using tags this time, the outcome is determined purely with positional matching. Let's see the example. I think it is much.
Professor, I have a question.
Sure.
So what if it satisfies, like, let's say two of them? What happens?
Do you think it is possible in this case?
In this case, it wouldn't be. But let's say, for example, let's say Homer was if condition was above 10, and Bart was if condition is above 5, and the number is 15. What would happen?
I'm not sure if we can add greater and smaller in this part. Like you say that
Okay.
like this.
No, if Homer was, like, let's appoint a variable, okay? A third variable, and let's call it A, for example. And let's put Homer equals A above 12 and Bart equals A above 5, and assign the variable A as the one that we're talking about, like it's the true variable.
You can't use switch for that kind of complicated parts. We are just using for this one, but why don't you try it, okay? Why don't you try it and just share your results with us? Because if I don't see the comment, maybe it's not too easy for me to get the idea there, okay?
Okay. I'll try it and
try it, and maybe you can share with us.
I think when switch gets the target or gets true, it just gets out of switch function. It doesn't go to the second condition or the conditions after this one.
Okay, she said that maybe if switch finds the first true, then it is not moving to the followings. Then just stop there and give the result.
Yeah, I think that would make sense.
Mm-hmm.
But I want to try it.
You should try, I guess. And also, while he's trying, we should move to the integer version. For example, I have my number as 3, and my foo is a switch function. Oh my God. So it is my expression, my number 12, 34, 56, 78, NA. Now when I foo, you will see that the switch function is giving me 56, the third one. That means it's just giving me the place of this integer. So we are just providing an integer, my num, as the first argument, and it is positional. It is positionally matched to expression. And in this example, we have 5 untagged arguments, 12 to NA. The switch function simply returns the value in specific position requested by switch in here, okay? So in here, my num is 3, you see that one. Then it's going to give you 56 because it's the third value in your switch function. But if you don't have any of them, any of the places, for example, we have 1, 2, 3, 4, and 5 elements. Let's say your number is 0. This is not included in here. And when you run this part, the switch function one more time, your foo is null because there is no 0th element in here. Or if it is, let's say 7, then you run this part. Again, you don't have the 7th element in here. So you have to have 1, 2, 3, 4, or 5. Okay? So if you need to examine multiple conditions at once, or you need to execute a more complicated set of operations, you will need to use the explicit if and else control structures, okay? Switch is kind of a basic one. So if you have kind of like multiple conditions, then you should use if else, okay? Do you have any questions? Comments?
All clear.
I think it's
We
pretty
can write some other maybe expressions there, right? It doesn't have to be just numbers, right?
It can be numbers, or like in here, it can be a string.
No, I mean in line 120, we can, for example, instead of 12, we can write 12 plus my number, for example. Right?
Instead of 12, what?
We can write 12 plus my number, for example, right?
Let's say. This is
But
supposed to be 1.
In this case, we need also to write 56
Yeah, now you can write that.
plus my number. Okay. Yeah,
So
yeah,
when
I got it.
when we speak at the same time, I'm having some difficulty to hear you guys.
I'm sorry.
No, it's okay, but maybe just to remind you. Okie dokie. Any questions, comments? Are you guys with me?
Yes.
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 very much.
Yes.
Yes, thank you.
Yes.
It's good to know there are some people there. So we will move to loops. Loops are very fancy in programming languages and also in R. Loops means that you are looping, you are cycling, you are repeating the same job, okay? I think that's a very basic programming part. And in functions, we will move to functions after that. We are using lots of loops. But to be honest, I hate loops and I try to avoid them, okay? But
Me too.
But of course, we have to
Same.
learn them. We have to learn them. We have to know how to use them. Sometimes we have to use them. But for the next semester, I will show you how can we avoid using loops. But
I heard a sentence in LinkedIn. It said that if you are using loop to solve something, then you are doing it wrong.
not always true, but yeah, it's just making your code maybe not that fast. It's kind of getting slower if you have using it with a greater number of objects in there. Maybe you should avoid loops. And sometimes, especially for R, there are some better ways to use instead of loops. But first, we need to know what are they, okay? So they are repeating a specific section of your code. And generally, you have incrementing an index or counter. Generally, you have counter. And for each step, you are just running them, okay? So there are two styles of looping. The for loop repeats code as it works its way through a vector, element by element. And the while loop repeats code until a specific condition evaluates as false. Okay, so in R, we can use apply functions instead of loops, but for this lecture, we will see loops in here. And I want to add you as a first example, I want to add you a for loops, okay? So here is a pseudocode, just to show you how it is working. So for loop index in loop vector, R is doing whatever you write in here. So the loop index is a placeholder for you guys that represents an element in the loop vector, okay? And it starts as the first element in the vector and moves to the next element, which with each loop repetition. Then for the second repetition, you are moving to the second one, okay? When the for loop begins, it runs the code in this braced area in here, okay? Replacing any occurrence of the loop index with the first element of the loop vector. When the loop reaches the closing brace, the loop index is incremented, taking on the second element of the loop vector. And the brace area is repeated. This continues until the loop reaches the final element of the loop vector, at which point the brace code is executed for the final time and the loop exits. Okay, so here is the example. Let's see a very basic example and you will get the idea. So if my item, for my item in 5 to 7, that means my placeholders are going to be 5, 6, and 7, okay? Let's see what's happening. Brace area begins in here, and the current item is what? My item. It is going to be 5, and braced area ends, okay? So, as a second step, it's just writing the braced area begins again, and the current item is my item. It is 6, and braced area ends. And for the third loop, my item is 7. Now it's just 7 in here. I think this is one of the great examples that can be explained for in a good manner. So you can also manipulate objects that exist outside the loop by using for loop in here. Let's see an example. For example, I have a counter. Let's start with 0, okay? For, again, my item, you can just give any name in here. In 1 to 7, counter equals counter 1, and you just cat something, the item in run, and then you just write counter in here is my item, and just go to the next line, n. So this one. So our counter is 0. Now I have my for loop. As you can guess, it's just running for the 5th, 6th, and the 7th of my item. That means this is just running 3 times. And I run this part. Now my item in run 1 is 5. My item in run 2 is 6. My item in run 3 is 7. Did you get the idea in here? What is happening?
Just give me a second. I'm trying to copy the
Sure,
code.
sure. So you see the difference between using the loop index to directly represent elements in the loop vector and using it to represent indexes of a vector.
I have a question.
Sure.
Will our number, let's say 5, where will it increase? Will it increase in the last line, like in the 140, it will become 6?
In here, after run this part, just before this guy.
Okay.
Good question.
So in 7, when it just becomes 7, it will stop exactly where?
It is 7,
I think it
and
stops.
and then here it is going to be 7, then it stops.
Okay.
But 7, but it is going to run this part just before the braces, then it stops there. Okay?
Hocam bir şey soracağım. Cat'te counter yazdık ya. O aslında counter plus 1 olması gerekmiyor. Yani 1 olması gerekmiyor mu?
Maybe you see that it's just starting from 0. Then 0 plus 1 is 1 here. Why it has to be
Ha, okey.
counted?
Tamam hocam. Tamam.
Mhm. So you see that maybe this is important in here, and I will add an example. The difference between using the loop index directly to represent elements in the loop vector and using to represent indexes of a vector, okay? So let's see what I'm talking about. Let's see the difference. I have my vector, just an arbitrary vector. You can use whatever you want, guys. 1.1, 0.34, 0.55. Okay, here is my vector. For I in my vec, print 2 times I. Okay, so here is my vector, and for each of them, I'm getting 2 times my vector, the value of my vector. Okay? But if you want to use in a different way, let's say for as a placeholder, if you want to use as a placeholder, I in 1 to length of my vector, okay, print 2 times my vector ith. Now it's just doing the same job in a different manner, okay? So in the first one, you are just using directly the elements in the loop vector. In the second one, you are just using the place of that vector, okay? There are 2 ways you can use. It's up to you guys. Whatever is easier for you, you can use whatever you want. Generally, I think I prefer this way. I don't know why. So the first loop in here, use the loop index I directly represents elements in my vector, okay? So the printing the value of each element times 2 in here. In the second loop, on the other hand, you see in the second loop, we use I to represent integers in the sequence from 1 to length. These integers form all the possible index positions of my vector, and you use these indexes to extract your vector's elements in here. I think even this seems kind of longer than the previous one. I would prefer that one, okay? Because it's more flexible. Any questions, comments?
I think, like, if ever there was a lecture that needed the most practice, because it's this one.
Yes, maybe.
Because it's going to carry on to all of our other topics.
Yes, but you will have recitation and you can practice there, and also you can practice by yourself. and we give you some homeworks, and then you will have enough comfort in that topic after a while, okay? Of course,
Hocam,
yes, Gülnaz.
tam dersi takip ederken bazen bazı şeyleri kaçırabiliyoruz da haftaya ders başında sorsak sorumuz olursa olur mu?
Sure. You can ask next week if you have any questions at the beginning of the lecture. Also, you can ask in the recitation. It's
Tamam.
up to you guys, okay? We are always open to your questions in here. But sometimes please try by yourself. For example, instead of using, okay, Dr. Instead of my vector, what if I can use my not vector? You know, I'm just trying to generate something. Maybe you should try some of them first and see how is happening. So it's a good idea to play with your codes in there, okay, by yourself too. And that doesn't mean that you cannot ask questions, but also it's a good idea to play with your vectors and your for loops and if statements, blah, 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 whatever you want. So I want to give another example, if you are okay. Can I add another example?
Yes.
Of course.
Sure.
Thank you. So here is my new foo. This is a list. I want to generate a list. Let's see, how can I make it beautiful? Maybe like this.
John, can you please send it to the chat?
Sure. Let's see, where is the chat? Okie dokie. Yeah, that one. I send it with chat too. So here is my list with 1, 2, 3, 4, 5 elements. Vector, matrix, matrix. What is this? String here. What was that? A string also, an object, okay? And also matrix. So here is my foo. I have my A, B, C, D, and E. You see that we also have a logical matrix in here. So here is the activity. Here is the activity, the class activity. You will write a for loop that goes through each member of a list like this one and check whether the member is a matrix. If it is, the loop will retrieve the number of rows and columns and the data type of the matrix. This is the class activity we have at the last point.